Good morning to all of you. Welcome you all for the lecture video on the topic Basic Civil and Mechanical Engineering. Myself, Dr. P. Sabarinath, working as Associate Professor in the Department of Mechanical Engineering, SRM Madurai College for Engineering Technology. This video is mainly for the subject Basic Civil and Mechanical Engineering, in which both civil and mechanical engineering concepts will be covered. So I am going to cover the mechanical engineering part. So in the unit 1, we have both the overview of civil as well as mechanical engineering. 50% will be from civil engineering and the remaining second half will be from mechanical engineering. So I am going to give the overview of mechanical engineering. What is the definition of mechanical engineering? What are all the sub-disciplines of mechanical engineering? What are the applications of mechanical engineering? What are the various domains available? Finally, the interdisciplinary concepts of mechanical engineering. All these things will be covered in the unit 1 under the topic of overview of mechanical engineering. Now we will see the definition of mechanical engineering. So mechanical engineering is a diverse and foundational branch of engineering. It is one of the core branches of engineering. There are some other core branches like civil engineering, electrical engineering. So mechanical engineering is also one of the core branch of engineering. It mainly focuses on the principles of mechanics, kinematics, thermodynamics, and energy systems to design, analyze, manufacture, and maintain the mechanical systems. So, mechanical engineering derives the concepts of uh, physics, mathematics, and other domains for the application of mechanical systems. So, from the physics, we are going to take the concepts of mechanics. Mechanics, we are going to see the statics and dynamics. When the object is in static condition, means it is at rest, it's not moving. So at that time, what are all the various forces acting in the body? For example, if your car is not moving, it is stationary. At that time, its own weight will be acting. Various components will be available in the car, so it has its own weight. That is called as statics. Suppose if the car is moving, that is called kinematics. When it is under motion, in addition to its self weight, other forces and stresses will be acting. So how to find out those stresses and how to design the component to overcome the stresses like that. Similarly, in mechanical, most of the systems will use uh, thermal engineering, that is heat. Thermodynamics is the concept of heat energy. We have heat transfer, various modes of heat transfer like conduction, convection, radiation. So all these aspects will be covered in this thermodynamics. So if you take a car engine, the fuel, petrol or diesel, the chemical fuel is converted into heat. From that heat only we are generating power to drive the vehicle. So that conversion of heat energy into mechanical energy will be covered in this thermodynamics. And energy engineering also one of the main branches of mechanical engineering, in which the various energy is converted into one form of energy into another form of energy. That is called the law of conservation of energy. For example, if you take a car, we are using petrol. That is a chemical fuel. That chemical energy will be converted into uh, mechanical energy to drive the vehicle. Like that, we have so many energies used in mechanical engineering. By using all these things, what we are going to do is we are going to design a component. For example, we take a car, it will have so many assembly of so many parts like engine, steering system, clutch, brake, like that. So individually, we have to design all the components as a individual design. Then we have to analyze whether the component design is up to the standards, whether it will withstand the forces, stresses, what material we have to use, like that. That is the analysis part. And after analyzing everything is okay, then we have to go for manufacturing of the real components. What materials we can use, what methods we can use. There are so many methods of manufacturing like casting, welding, forging. We have many machines also like lathe, shaping, drilling, milling. Nowadays, the CNC machines are also used for manufacturing of mechanical components. So all these things we have to apply in the manufacturing part, and we have to maintain the mechanical system. So this is the main definition of mechanical engineering. So in mechanical engineering, we are going to mainly design the components. We have to analyze the components. We have to manufacture the components. We have to finally assemble as a final product. For all these things, we are using the basic concepts derived from other branches like physics, mathematics, thermodynamics, and energy engineering to design the mechanical engineering. So, in the view of application point of view, all industries, starting from the household appliances to the latest extensive industrial machinery like aircraft, for all these things, we need uh, mechanical engineering. Now we are going to see about the various sub-disciplines of mechanical engineering. First, we saw about the definition of mechanical engineering. Now we are going to see about the various sub-disciplines of mechanical engineering. So we have automotive engineering, aerospace engineering, thermal engineering, manufacturing engineering, like that. In automobile engineering, it is focused on the design and production of vehicles and their components. For example, if you take a car, it is a four-wheeler. In the car, you have so many subsystems like engine, steering, clutch, brake, like that, gearbox, like that. So each component we have to individually design. Then we have to finally assemble. What are the materials we have to use? What are the forces will be acting when it is in static condition, when the car is in moving condition? All these things we have to analyze. We have to design the components. We have to finally assemble the components. Then only it will be manufactured as a final product. It will be manufactured as a final product to the delivery of the customers. So all these things covered under automobile engineering. Then aerospace engineering also similar to automobile engineering. Instead of automobile components, here we are going to design aircraft and spacecraft. So here also we have to do all the components like designing of the parts, analyzing the parts, then assembling of the parts as a final aircraft or spacecraft. Then we have to manufacture using various mechanisms and machines and tools as a final product and deliver to the customers. The next branch of engineering is called thermal engineering. So already I said about heat heat transfer technology like convection, conduction, radiation. So many types of heat transfer is there. So most of the mechanical system uses heat energy. So mostly we are converting heat energy into mechanical energy. We take a steam turbine and the heat energy from the steam coming from the boilers will be used to convert the heat energy into mechanical energy to produce power in power plants. If you take a thermal power plant which produces electric power, but the basic source is heat energy. Water will be converted into steam in a boiler. That steam will be sent to the steam turbine, and the turbine will be rotated, and it will be generated as a power. So all these things will be covered in the thermal engineering, like boilers, steam nozzles, steam turbines. All these components will come under thermal engineering. Then manufacturing engineering is a very vital branch of mechanical engineering. So after design and analysis, we have to go for production. That is the manufacturing of the parts. So we have so many manufacturing methods like casting, welding, forging, sheet metal work, machining operations like lathe, milling, shaping, grinding, and also recently computer numerical control machines also available. So all these things are covered under this manufacturing engineering. And we have recent advancements like robotics, mechatronics engineering, and biomechanical engineering. Nowadays, all the industries are going for automation. So for all automation purposes, manpower will be replaced by robotics. So the manufacturing of robotics comes under mechanical engineering and mechatronics engineering. It is a fusion of mechanical and electronics engineering with the help of computer technology also. So we are using lot of sensors, programmable logic controllers, PLCs, the electronic components like microprocessor, microcontrollers to control the mechanical system. Instead of manual mechanical control, uh, electronic based control system like use of sensors, PLCs, even in a car, recent cars uses sensor based technology, mechatronic technology for burning the fuel, for controlling the speed, everything. This is an example of mechatronic system. The smart watches, mobile phones, all comes under the example of mechatronics engineering. And one more field is biomechanical engineering, that is also biomedical engineering. Now all the doctors, surgeons are now using robots instead of manually doing operations. Robots are implemented for doing the surgery, for doing laparoscopic surgery, specially designed tools, equipments now come for usage for doctors, assisting the nurses and doctors for doing the complicated surgery in a very easy manner. So those concepts are covered under the biomechanical engineering. Thank you for the opportunity.